Hi, everyone. My name is Sarah. I'm a PhD candidate at the University of Guelph. Today, I'll be presenting on behalf of a group of researchers that are investigating watershed behavior and nutrient transport in an intensively managed agricultural watershed. Next slide. So, continued research and innovation towards water management in southwestern Ontario is important for the health of growing communities within the Great Lakes Basin. There has been an increased recognition in policy for integrated surface water and groundwater monitoring, such as the recent COA agreement that identified groundwater surface water interactions as an area of focus. The objective of our work is to use monitoring, modeling, and machine learning techniques to better understand hydrologic dynamics and nutrient transport in an agricultural watershed in southwestern Ontario. Next slide. Thanks. Research is conducted in the Upper Park Hill watershed within the Asable Bayfield Conservation Authority. The watershed is dominantly low permeability soils and consists of mostly tile-drained agricultural fields. So the picture on the right, the green shaded area, is just all the tile-drained areas in the watershed. Next slide. To date, there have been 6 publications from the work in this watershed that includes nutrient transport, integrated modeling for climate change assessment, and geomorphology. Sorry, next. Work is still continuing in the watershed, which I will highlight in the next few slides. The first study is using isotopes to enhance watershed monitoring. So this study compares insight from monthly sampling of stable water isotopes and radon to more conventional monitoring parameters such as conductivity and chloride. Variables were evaluated in the context of defined watershed monitoring objectives, such as characterizing baseline conditions, evaluating watershed resilience, and examining contamination vulnerability. Ultimately, isotope incorporation has proven to be valuable complement to traditional monitoring metrics and has the potential to provide insights such as seasonality of recharge, evaporation, and groundwater surface water interactions, and possible impacts of climate change on watershed processes. Next. As an example of incorporating isotope sampling in a monitoring program, we monitored an edge of field site in the watershed for both nutrients and isotopes from multiple water components, including groundwater, soil water, tile flow, and surface water. We saw that the soil water exhibited similar signatures to precipitation, and in the summer and fall, the tile water signatures were similar to the soil water, indicating that tile flow is likely young water from recent precipitation carrying nutrients from field to surface water. The exception to this is in the spring when the tile water was more similar to the groundwater signature, which aligns with the rising groundwater table due to winter melt. Isotopes were a useful addition to nutrient sampling for insights on water sources to tile and surface water from an edge of field site. Next. The final project I will share on today is the application of machine learning for classifying nutrient concentrations. So the main scope of this work is to apply different classification machine learning algorithms using several different parameter inputs, which are listed on the left in the blue circles, as inputs to characterize nitrate and phosphorus concentrations in surface water in high and low classes. This was done for three thresholds. This was done for 3 observation locations in the watershed. Sorry. The high and low thresholds were determined based on water quality standards such as the Provincial Water Quality Objective for phosphorus and the guidelines for aquatic life for nitrate. The performance of each algorithm was evaluated using a group of evaluation metrics, confusion matrix, and ROC. For example, the confusion matrix on the bottom right shows that 96% of the time the model characterized the high class correct, and 65% of the time the low class correct. And this resulted in an area under the curve 80 for 88%. And final slide, thank you to everyone that has supported this project, and thank you for listening to this presentation.